probably a few of you groaning at home after you read that title, seeing the lovely, lovely word algebra in there. This is where matrices has a bit of a crossover with algebra. We can use inverse matrices to solve algebraic problems. Now in the past, if you ever had to do it by hand, what you would have done is you would have transposed equations, meaning like you do to one side, you do to the other. If you had x plus 6 equals 4, you would subtract 6 from both sides to solve for x. Or if you had 3 times x equals 9, you would divide both sides by 3 to solve for x. It doesn't work that way in matrices because you can't divide a matrix by another matrix. Division doesn't really exist so much within matrices. So we need another system. And this is where we use inverse matrices to be able to solve problems. Now, what we're going to do again is write out a bit of a formula, use algebraic sort of terms and use variables to show how it's done, and then do an example or two. Now, let's say you've got a problem. I will use numbers in this one, but won't solve it until later on. Let's say you've got this matrix multiplied by this matrix equals another matrix. So 2 by 2 by 2 by 1, so it's going to equal 2 by 1. So you've got these numbers, 4, 2, 5, and 3. And then the answer is going to be 8 and 11. So what we're doing is we're taking a matrix, we're multiplying it by another matrix, and it's going to equal 8 and 11, a third matrix. Now this is where we have an unknown matrix. So in previous algebra, you had an unknown variable, x, y, z, a, b, c, whatever. In this case, you can have whole unknown matrices. Typically when we do this, the unknown matrix is a 2 by 1. That's just sort of the easier one to do, and that's where we can demonstrate our skills. Now, they'll usually be shown like this. Because it's got 2 elements, it'll have 2 unknown variables in there. The default is usually x and y, depending on the question. It might give you a and b, or m and n, or whatever, but x and y is the typical one. Now, for now, we're going to denote these matrices with different things. I'm going to call this one A. Typically, if we have an unknown matrix, we can refer to it as matrix X. And I'm going to call the answer matrix, or the product matrix, B. So right now, what we have is A times by X is equaling B. So if I was just to simplify that, AX equals B. So essentially, what we want to do here is we want to solve for X. A and B, we already know what their values are, but what we want to do is solve for X. Now, if this was any sort of case in normal algebra, you would divide both sides by A because we're multiplying by A. But as I said, in matrices, we can't divide by a matrix. So we need another system. This is where inverses come into it. I'm just going to go get my marker that I just threw away. All right, like we did with finding the inverses, we're going to use a very step-by-step process. Step 1. So instead of using division, we're using multiplication. We're going to multiply both sides of the equation by, anyone want to have a guess? The inverse of A. A is what we're going to get rid of, so we're going to multiply both sides by the inverse of A. What this is going to look like is this. So originally this was our equation. We're going to multiply both sides of the equation by the inverse of A. So I'm going to multiply this one by the inverse of A. I'm going to multiply this one by the inverse of A. Now, one really important thing here, you want the inverse of A to multiply directly to A. So if this was swapped around, say it was XA, then you would multiply the inverse to the end. You want that inverse directly next to the A, because when they multiply together, they're essentially going to cancel each other out. It's going to equal the identity matrix. Now, wherever you position the inverse of A on this side, you have to position on the same side on this equals. So for example, here it's on the left-hand side of the AX, so you must put it on the left-hand side here. If we're multiplying on the other side, then you'd have to multiply on the other side of the B. We can go through a few of these examples if that doesn't make too much sense. All right. That's our first step. So if you were doing a full question, which we will solve this one later on, you would need to first find the inverse of A. So when you're doing these questions by hand, they're pretty time consuming. They do take a while. Alright, so what we should by now know is that the inverse of A multiplied by A is going to equal the identity matrix. So what we can do, that's pretty much our step, is just rewrite this again, but instead of A, its inverse multiplied by the original, it would look like this. Alright, identity matrix multiplied by X equals inverse of A multiplied by B. Step 3. We should know, hopefully, that if you take an identity matrix and multiply it by any matrix, it doesn't change the matrix. Remember, the identity matrix is just essentially the number 1 in matrix world. So identity matrix multiplied by X is like saying 1 times X, which just equals X. So again, we rewrite this, it now looks like this. So what we've done is we've actually, in a way, transposed the equation so that X is by itself. Originally we had this, we've followed these 3 steps, which equals this. As I've said in previous videos, once you do this skill a few times, you will get more confident at it and you will be able to skip through steps. I'm going to just rewrite this but slightly more condensed. So step 1. Oops. Looks like that. Step 2 looks like this. And step 3 was where the I disappeared. It's like in algebra, where if you've got a variable, you don't write 1a, because that just means 1 times a. You just write a. And that I there does not need to be there. Now, once we do a problem, we get to this. We haven't actually finished it yet. We would then need to multiply the inverse of A by matrix B to then get the final answer. Let's have a go at it. We're going to do this matrix here. Alright, so I'm not going to rewrite this whole problem out again. It's right here. First step is to multiply both sides of the equation by the inverse of A. We don't have the inverse of A, so we need to actually solve for that first. Okay, first thing I'm going to do is I'm going to work out that AD take BC. Then I'm going to put that in a fraction on the denominator with the numerator of 1, and then swap the elements and multiply them by -1 where necessary. So, AD minus BC equals A times D, 4 times 3 is 12, minus 2 times 5, which is 10. Alright, so my AD take BC is equal to 2. Alright, the inverse of A is going to be equal to 1 over the AD take BC, which is 2, so a half, multiplied by, alright, so remember, we swap elements A and D, and then we multiply elements B and C by -1. So this becomes -2, this becomes -5. When it comes to these questions, it's better to get rid of the fraction, not keep it there. So we need to multiply a half to each of the elements within the matrix. You can use fractions or decimals here, it doesn't really matter. I'm going to use decimals. Half times 3 is 1.5. half times negative 2 is negative 1. A half times negative 5 is negative 2.5. And a half times 4 is 2. Alright, so we found the inverse of A. Now what I'm going to do is I'm going to rewrite it out like this, the whole thing in one long equation. See if I can fit it. So the inverse of A is going to multiply to A, which is going to multiply to X, which is going to equal the inverse of A multiplied by B. Alright, so there's a lot going on here. It can get quite complicated. Alright, so the inverse of A is this one, so I'll fill in the elements. Multiplied by A, this one. Multiplied by X, so X is the one with the unknown variables, equals the inverse of A. Multiplied by B, which is just 8 and 11. Alright, so that's quite a lot. Now remember, inverse of A, I'm just going to label this just so I can keep up. These two multiplied by each other will equal the identity matrix. Then the identity matrix multiplied by xy will just equal x, the matrix. So what I'm going to do here is I'm just going to cross these out because they essentially cancel each other out. They equal 1 for the identity, so they don't need to be written there. So I'm just going to rewrite this again. So it's going to be the matrix X is equal to the inverse of A multiplied by B. Now we pretty much just have one more step. Multiply these two matrices together. Don't know if I'll fit it, but I'll try. Alright, so run and dive, 1.5 times 8 plus negative 1 times 11. Run and dive, negative 2.5 times 8 plus 2 times 11. Alright, I'm just gonna, sorry it's getting a bit messy. Okay. 1.5 times 8 is 12, negative 1 times 11 is negative 11, so 12 plus negative 11 is 1. Negative 2.5 times 8 is what? Negative 20, plus 2 times 11, 22, so negative 20 plus 22 is 2. It's a lot of work for two numbers. What you can also do is when you write your final answer, so we know now that xy is equal to 1, 2. So therefore, remember this symbol means therefore, x is equal to 1, y is equal to 2. So it's a lot of work there for two little numbers. This is probably one of the hardest things we'll have to do in this topic. It does take a lot of practice, it does take a few goes. I'll probably upload another video with another example of these, just if you want a bit of extra help with them, because they are quite complicated. Again, make sure you're using the Google Classroom to tell me whether you're not understanding things and if you need help with specific questions. But yeah, I will upload another video in this lesson plan as an optional one to do another example of this if you need it.